computer. Hello, Samantha. Okay, I think we're good. All right. So welcome everyone to the May 11th edition of Our Ladies Dallas. My name is Sadika Watson, and I am currently serving as organizer of the Dallas chapter of Our Ladies Global, which, as I'm sure you may be aware, is an organization that supports women who are using the R programming language and navigating through their tech careers using R. So what we've been doing during COVID is to, of course, because we weren't hosting in-person events, we've been hosting a really nice webinar series. So we've been blessed to have a really cool lineup of speakers from all over the place. We've actually had an international speaker even, so it's just been really cool to see people outside of the Dallas area, not only joining us as speakers, but also joining us in the audience. So yeah, if you wouldn't mind in the chat, could you just kind of let us know where you're calling in from? So I'm sure we'll have some representation from Dallas here, but maybe just let us know which city, if you're in which city and state, if you're in the United States, which country you're from. I see some local people in Dallas and Austin in the chat. Michigan, lived in Dallas 8 years. Nebraska, Denton, Texas, Tyler, Texas, lots of Texas representation here. I'm just outside of Garland here. New York. Oh, I can't wait to go back to New York. Okay, we've got representation from Brazil, from Mexico, Irving, Texas. Oh, this is so cool. We've had people from Cameroon, from Turkey, just everywhere, thanks to this. And so this is just so special to have people from all over joining us. So yeah, from wherever you are, yeah, I definitely welcome you. So yeah, before we jump into our speaker, I definitely wanted to make sure you were aware of our upcoming sessions. So let me share my screen very quickly. So on the Our Ladies Dallas page, we've got in the list of events, obviously the event that you came to see today, but we also have a couple of speakers lined up, actually 3 more speakers lined up. We've got one of our speakers is actually in the audience. Danica Slavish is joining us today, but she will be our speaker on June 1st, talking about latent profile analyses using Tidy LPA. And then we also have a couple of other speakers. Dr. Janani Ravi from Michigan State University. We haven't received her topic yet, but she'll be joining us on June 15th. And then we have another one coming up on July 1st from Prathipa Jaga. So this is going to be super cool. Yeah, so one thing that obviously we have some speakers lined up here, but if you're interested in becoming a speaker, feel free to reach out to me and let me know if you're interested in giving a full presentation, or maybe you just want to give a lightning presentation. You've got something that you've been playing around with, maybe just some code or some R package or something like that you'd like to share. Maybe it doesn't have to be something formal. And maybe it could be short, like a 5 to 15-minute presentation. We're welcoming lightning talks and full talks as well. So yeah, feel free to reach out to me if you are interested in that. And yeah, I think that's everything. I think we're good. I think we're ready to get started. I think everybody's just kind of excited about the speaker. I'm excited about our speaker. And the topic of, reproducibility and flexible workflows and so on. I mean, I know it's something that people talk about a lot, but, I think there's different perspectives that we get from everyone, so I might talk about it one way, somebody else might talk about it a different way. So I'm definitely excited to see today's speaker's perspective on that topic, especially given the way that she's framing it in terms of, making things dynamic so that they can really accommodate some of the different types of really unique use cases. So definitely excited to see that. So not only will we be talking about reproducible workflows, data workflows, but we will also, a really nice treat is that our speaker, Brooke Watson Madubuonwu, is the director of the Legal analytics, and quantitative research at the American Civil Liberties Union. And so that's just amazing. She's doing a lot of great social justice work in lots of different areas: criminal justice, housing, education, gender, racial disparities, and voting equity. And before she joined ACLU, she trained as an epidemiologist at the London School of Hygiene and Tropical Medicine. She studied zoonotic viruses as a research scientist at the New York-based nonprofit Eco Alliance, and she completed her undergraduate studies in biology at the University of Texas. She's from Memphis, Tennessee, and I'm sure she enjoys long walks on the beach and all kinds of other stuff. So I'm sure she'll probably sprinkle some other fun facts about herself as she introduces herself and goes through her talk. So without further ado, I'd like to welcome our speaker, Brooke Watson Madubuonwu. Thank you very much. And yeah, take it away.
Thank you so much, City again. Thank you to everyone for joining. I'm really excited to be speaking with this group. I am a dedicated Our Ladies member of Our Ladies New York and a former organizer and board member with that group. So really excited that I can be joining Dallas, and it sounds like a lot of other folks virtually today. And I'm excited to be, as Sidika mentioned, speaking about a subject that I think even Our Ladies Dallas has been covering recently, reproducibility. And so about half an hour ago, learned that that a January speaker, Dr. Seyoung Kim, had presented a really great introduction into reproducibility and why it's important to strive for reproducible workflows. And I am hoping to extend on that. I think I have really bought into the need for reproducibility and came to my role at the ACLU 3 years ago thinking that I would just automate a bunch of things and set up a bunch of really productive pipelines and create a ton of efficiency. And then as I started to do that work, found myself running into lots of bugs and errors and found that to be a little bit more tricky than I had originally thought. So I'll go ahead and share my screen and maybe I can get a thumbs up from someone that that my slides are visible. Awesome. So today I want to talk about what I want to call resilient reproducibility or flexible reproducibility, sort of how to keep your data analysis pipelines and workflows consistent when your data structure might not. So as Sidika mentioned, I work at the American Civil Liberties Union, which for folks who don't know is an organization that that advocates and defends civil rights and civil liberties in the courts, in the legislatures and the streets. And so what that means is that we sue the government a lot whenever it's violating people's civil rights or civil liberties. And so I find myself frequently and my team frequently needing to make reproducible reports using data that comes from municipal government data systems from a bunch of different jurisdictions, often from places that may not be invested in the latest technology and needing to make those reports reproducible over time. And so have learned a lot through a lot of trial and error about how to make those pipelines a little bit more adaptive to having humans in the loop or having other kinds of surprises along the way. And I don't think this work is really unique to the ACLU. I think a lot of folks working in academia, in nonprofits, maybe even in startups and industry, are working with data that changes in structure and format over time. And so I want to share a few sort of lessons I've learned the hard way along the way. So I'll start with this quote from Hadley, Wickham via Tolstoy, that tidy data sets like happy families are all alike, but every messy data set is messy in its own way. So I think one of the goals that I'm often striving for in reproducible analysis pipelines is getting to that clean data set that you can then analyze over time. And that's often the biggest challenge. So quickly, I'll cover my definition of resilient reproducibility, talk about some principles and strategies that have helped make reproducible scripts more resilient, and talk about some of my favorite tools, functions, packages that can support this work. I'm not addressing scientific reproducibility here. So the concept that the results of an experiment should be generalizable beyond that particular environment. I'm sort of talking about reproducibility in code specifically, but just to note. So to define resilient reproducibility, I want to start with what I think reproducibility is. So in theory, reproducible workflows make it possible to repeat analyses in different environments or with new data. Jenny Bryan at our studio talks about treating your session like crops, not houseplants, which I think means being willing to kill a session if it's not working and not being precious about your particular session. And session being your R environment, the packages you've loaded, maybe the version that you're using, et cetera. I think there are ways in which you can also treat your sessions like crops, meaning not be precious about them. And some of these principles apply to your data set. So in theory, you should be able to run data through a pipeline and get to an updated result every time. And in some cases, this is possible. A lot of automated data, you might have an ETL process that takes your data, that transforms it, that loads it into even something like a dashboard, and that is updated instantaneously, that's repeatable, that's general, and may require more initial investment, but then can be instantly updated versus one particular data set that you might collect once. It might be a really laborious data collection process. It might be really specific, and that process is very time consuming and custom. And there are definitely instances where that personalized custom process is really appropriate. So if you're collecting data one time, you're not going to have to update your analysis. You do want to make sure you document all your work, and a lot of reproducibility sort of principles can help with that. But you might not need to rerun this. There's an area in between the sort of like one-off project and this automated, automatically updated data flow that a lot of the work that I do lives. So often we're running reports monthly, we might, or even quarterly, sometimes weekly. So the data is updated over time, but not quite frequently enough that building out a huge investment of something like a dashboard is necessarily appropriate. The other thing that can happen is that the data can change slightly in format over time. So sometimes there's a human in the loop component where individuals are entering certain data sets. This is just a small selection of some of the problems that we've had with different monthly updates over time. So sometimes there's hand entered, hand updated fields. Maybe the column names are updated every time a different data entry person or analyst goes in and updates the data. Sometimes folks use different formats based on who's delivering that data. We had one instance in which, depending on the day of the week that a particular person was working at an office, a data report would be delivered in horizontal format or in vertical format. And we had no control over that and had to build entirely separate processes for the two sort of PDF formats that we were trying to extract. Sometimes PDF formats change slightly, unpredictably, for reasons that we can't really anticipate, but for reasons that kind of break brittle analysis pipelines. Sometimes certain variables are missing if, for example, there were no instances of a person who had a particular kind of data in a certain month. And sometimes there are no observable reasons that the agency that we're working with, or the municipality that we're working with, is running a deprecated data reporting software on old machines that they wish they weren't working with, that you wish they weren't working with. Neither you nor the team producing the data, nor the original creators of the software, the purchasers of the software, understand why formats change, and you might not have control over that process. So a lot of different things can happen. And so these can really extend out the time that you're taking to to build your automation pipeline. So this is the classic XKCD that I think is mandatory for any tech talk. This is certainly what I thought was going to happen when I started working at the ACLU. I thought I was going to come in and start creating R Markdown scripts that would, take a little bit of time. Maybe they were not as quick as analyzing data in Excel, but over time, I could fully automate them away and free up more time to work on different projects and save that team a bunch of reporting time. And in reality, a lot of things can go wrong in that process. So you'll run into bugs, you'll run into errors, you'll get everything sorted and then get new data the next month and everything has to change. And then it takes way longer than it originally should have. So this is the fundamental challenge that that has led me to want to be more resilient in my reproducibility. So in practice, with automated data, sometimes these pipelines can break. They can produce errors that are not very interpretable, or even worse, they can not throw an error and produce inaccurate results. So if you're, sometimes you might notice, because the script literally won't run, sometimes you might notice something is broken because you're getting NAs or you're getting negative values or things that are impossible. And sometimes you don't notice that the script is broken, but you find out later, or perhaps not at all, that you're getting inaccurate results. So it's not always appropriate to treat data sets like crops in this grand metaphor. And so this is often the instance that I find myself in with reproducible scripts, where I've set something up to run perfectly, but I have to do a lot of coaxing along the way to fix the bugs, and end up spending maybe a lot more time than I would have otherwise if I had just taken a more manual approach. So while reproducible workflows make it possible to repeat analyses in different environments or with new data, making those workflows more resilient can help you sort of flex and adapt to surprises in that new data, or tell you at least when they can't flex to those surprises, so you can really quickly identify those errors. So I have sort of three strategies for generally leading to more resilient reproducibility, and I plan to share a bunch of packages and functions and tools that have helped me with these strategies. So the first is just staying as general as possible, and we'll work through an example with some dummy data that I unfortunately did not get on GitHub as quickly as I wanted to, but that I plan to share afterwards. The first strategy is staying general. Second is stating your assumptions, encoding your assumptions directly into your report, so that your code fails loudly if it does fail, and you're able to identify those errors more quickly and easily, so that you can fix things. And then always looking at the data. I think I had a conception early on in my data career that I would eventually get to a place where I wouldn't have to look at the raw data anymore, because I would be so good at coding that I would never have to go into that more manual phase. And what I've actually learned is that there are more efficient, more interesting, more insightful ways to look at the data that I'm hoping to share. So first, staying general. I want to walk through a little example, sort of stepping up from something that we know is not reproducible. And if you're in this talk, you've probably already moved past something like finding an error in a spreadsheet and fixing it in Excel in the raw data. I think most of us hopefully would agree that, though we've all done it and may find it appropriate to do sometimes, that this is the least reproducible approach, going into the raw data and changing it. And I think I would advocate for never changing raw data, even when it's really egregiously wrong. The first step towards reproducibility is just moving that fix out of Excel and into R. So making sure that you're saving the raw data, showing your work, and tracking what you're doing. You can do that for one particular value, or you can do that for example, a pattern that you're finding in that bad value across a whole column. You could find that bad pattern and fix it across a whole data set. beyond just a single value or a single column. You could find, you could expand what you think are maybe bad patterns, and I'll walk through an example of this. And finally, you can wrap all that process into a function that you can use across multiple data sets and fix things in multiple places. So the example that I'll use is a single instance of an incorrectly formatted date. I've just taken the Star Wars data set and added a data date column. And unfortunately, for one value, we have this data date that is formatted in the wrong way. We've got year, month, day data, and here we have month, day, year data, or day, month, year data. We actually can't tell from this value. You'd have to figure that out from context clues or from the other data. So you can just do it in Excel. I'm not going to knock it, but I will encourage folks to move away from that practice and hopefully learn some tools to do that. You can change a single value in R. So I've named this data set helpfully and descriptively SW for Star Wars. And the index, as we saw, is the third row of the fifth column in the fifth column. So we can just fix that in R. That's a little bit better than fixing it in a place where we can't track it at all, right? Or we could fix it across the whole column. So here we're using a mutate. We've changed the name of our data frame helpfully, but let's pretend it's still called SW, and we're mutating this date column, which also maybe I changed. So demonstrating a lot of good reproducibility in my examples here. But we've got this date column, and we're mutating every instance of a value that is 1119 to 2019-0101. So solutions 2 and 3 are reproducible. You can rerun that code over and over again. If you change other values in your raw data, or you add more raw data, those are always going to fix that error. But they're a little brittle because you might have different errors in the future, especially if your data is updating month over month. So as we continue to move toward more resilient, reproducible fixes, next we have pattern detection. So we can mutate a whole variable. This is, I think, an example of something that I thought was very clever the first time I did it, where I'm saying, okay, I'm going to look for a slash. And if I find a slash, that tells me that this is a month, day, year format of a date rather than the dashes. And I'm going to lubridate, use the MDY function from lubridate on everything where I find slashes. And I'm going to use the parse date function for everything else in my column. That feels pretty clever. I was very excited when I landed on a fix like this for some data that I was dealing with, but then naturally found some different forms of errors. So there's a couple of ways this could go. You could find more dates that are formatted incorrectly that aren't caught with this slash. But you could also find some dates that have that slash, or some values that have that slash, but that actually aren't in this month, day, year format, and you would need to fix differently. So here I have a pipeline where I'm checking if the date is in month, day, year format, or month, day, year format. So I'm basically using this ugly regex string to say, are there 2 digits before a dash or a slash, followed by 2 digits, 1 or 2 digits, excuse me, followed by a dash or a slash, followed by 2 to 4 digits. And if so, then I want to use this lubridate function. And if not, then I'm going to parse the date like I did before, assuming that it is still year, month, day. And that works on a few more cases than the previous version. But you can also get different kinds of errors. So often in my workflows in the past have come to a solution that works for example, January data. And I write my reproducible report, and I am certain that in February, I won't have to make any changes when I get new data. And then February data comes and we have a new kind of error. So here in the date column, again, we have the month, day, year format, but we also have this random string of 5 numbers, which for folks who work frequently with Excel data might recognize as an Excel native format for storing dates. And this is often when I'm reading data in from an Excel file, how the data shows up. So ultimately, the more text I want to build, I'm going to want to put that into a function. So here's an example of a function called check and fix date that takes a data frame and a date variable. And I've broken this out into just 2 steps. You could do this in 1 step, where essentially I'm detecting a format based on the pattern of the date variable. So here I'm looking for that string that we looked for earlier and saying if it's in that format, then this is a month, day, year date version. If there are 5 digits in a row, then this is an Excel date format. And then if we've got 4 digits, 2 or 4 digits followed by 2 digits followed by 2 digits, then we've got month, year, month, date, essentially. And I think there may be some challenges with this format, but it should be reasonably reliable. And you could combine these 2 steps where you're checking and cleaning, but I thought that this was more intuitive, parsed out. And then based on the date format, I'm going to use a different function. So I really like parse date from Reader, the MDY function from LubraDate, and the Excel numeric date function from Janitor. And so we can just do that over a whole column and fix for date. This is not going to fix all dates, all versions of a date. So for folks who are based in the UK, for example, dates might be, or in other countries, dates might not always be in month, day, year. There might be some places where dates are in day, month, year. And so you really have to understand what kind of data you're working with to be able to determine the appropriate fixes. So I want to briefly make a note on the sort of different XKCD that we looked at earlier, where we're spending more and more time automating and trying to anticipate more and more problems. So I want to briefly talk about sort of over-engineering problems. I think this anticipates a few different formats. And in fact, because we often deal with data sets that come in where dates come in multiple formats, this is moving towards something like a function that we could use across multiple places. But it's also the case that the date could come in an entirely different format. It could just say Jan space 1. You could have a date that says 3 days ago. So it's not always going to be the case that you can automate everything away. So there is a balance to strike between the amount of time you spend trying to automate something and the amount of value you're getting out of it later. But I do want to make a pitch for automation, not just to get back the exact amount of time, but to get back that time when you need it most. So I really liked this quote from a blogger who was writing about this, sort of saying that automation can be like a battery as well as an investment. So putting energy into reproducibility pipelines, not only can they sometimes improve accuracy, they can improve the transferability of your analyses, but they can also give you energy in the times that you need it. So maybe you have a big report that you have to do quarterly, and it's helpful to be able to release that report as soon as the new data comes out. It might take you a little bit more time to create a automatable, reproducible script, but you might get that time back in a time when you really need it. So I think this is how I've thought about when and how to invest in these reproducible pipelines. So the second sort of general strategy that I want to talk about is encoding your assumptions. All computer code contains assumptions. I think we saw earlier that I'm making a big assumption here that that values that are in this particular format, where there's one or two numbers followed by 1 or 2 numbers followed by 2 to 4 numbers, that's going to be a month, day, year, date format. It's not always going to be that, right? So we have to tell R that that's what we're expecting, and we want it to fail really loudly if that's not what we're getting back. So I really like different packages that help with adding assertions of verifications in your code to help ensure, one, just that your code is doing what you think it's doing. Two, that you have all of the columns and classes you need. And three, that your data fall into plausible ranges for given your expectations. So in three, we're really bringing in a lot of subject area expertise to make sure that your data is falling into the right set of values. So here's an example with the verify function from the asserter package. So in using our check and fix date function from earlier, we're taking a messed up data set, we're checking and fixing that date, and then we're doing some assertions on that clean date, right? So we want to verify that the data frame is a date, and is date, I think, is also a function from the assertive package. And we want to also include our expectations about what the data should be. So in this made up example, I might say that I want to make sure all of the data is from at least the 1900s or later. I might set that wherever makes sense for me for given my particular data set. But this is a made up example. So I think including plausible ranges and sometimes a limited amount of variance around those ranges can help you make sure that your data is falling into your expectations. The second function that I have gotten a lot of value out of is dplyr all equal. So earlier we talked about the use case where some columns are existing in certain versions of a monthly report, but not in others. So for example, no one in February had a particular instance of some variable. And so that column might be missing from a report. dplyrs all equal can tell you both whether the columns are the same number or whether the data sets are the same size in terms of columns. And it can also tell you which rows are existing in one data set, but not in another one. And it will return you a true if those data sets are all equal. So this is a really useful gut check before you go into a full sort of analytical pipeline to make sure everything is meeting your expectations. And then finally, I also really love and have started using recently the assertive package, which includes a lot of custom specific functions for checking really specific things and also makes it easier for you to build your own custom functions. So 3 examples that I wanted to share are the is in past function. So you can check to make sure every value in a particular variable is in the past. You can check that a particular file path is readable before you read it in. And you can also, there are really a whole range of really custom assertive functions. So this one is US telephone number that checks whether something in a particular data set is a phone number. There are ones for zip codes, for lat longs and things like that. So I will share these slides around after the talk. And this vignette I have found really, really useful for thinking about what other assertions can I add into my pipeline. So to go back to our houseplants crops metaphor, I think not all data sets can be treated as crops, but if your data does have to be a houseplant, you want it to be really communicative. So I'm not a great houseplant parent, but I do best when it's really obvious what my plant needs. So here is an example. Some plants are more communicative than others. I have one that I'm struggling with right now that looks the same when it's overwatered as when it is underwatered. And that makes it really hard. And sometimes that happens with functions as well, and error messages as well. Sometimes I can't tell the direction of the problem I'm having. So you want your code to be really, really communicative. And if something is wrong, you want it to tell you what the problem is. And so building in assertions and validations and verifications can help you do that. So finally, my third general strategy with a lot of use cases that I really like is just looking at your data. And I want to walk through a few different packages that I think are sort of more on the niche side, and but that have been really helpful for me in these pipelines. So DAF is one package I love to check changes between two data sets, which has these two functions, diff data and render diff, that can show you a color-coded HTML file of the changes. VizDat is another package that shows missing data, can show whether or not data is meeting a particular expectation, and that can compare two data sets before and after, sort of similarly to DAF. And there are a couple others that I want to walk through. So first, diff data and render diff. This has been really useful in several cases where we are tracking class members of a class action lawsuit over time. So often we might receive a running list every month of class members for a particular lawsuit and corresponding information about them. And we want to understand not only how many people are added month over month, but also who is anyone being removed from the class? And if so, why? And can we follow up on those instances? So this is, I am too afraid to do live coding, but I did record a GIF of this package in action, rendering a diff and showing the HTML. So this package shows you which columns have been modified, which values also have been modified, deleted, or added, both columns, rows, particular instances. And so this is really useful in cases where just looking at the number of rows or the number of columns isn't going to be enough. Using something like dplyr all equal can sometimes do this as well, but the visual effects are really helpful for me, particularly in communicating this information back to stakeholders. VizDat has VizMiss, which visualizes missing data, and VizExpect, which can visualize expectations around data. So using our example data set from earlier, which is just a few columns from the Star Wars data set and this fake date column that we made up, we can visualize where the data is missing and understand better which observations might be a problem, which variables might be a problem. And we can also, sort of going back to thinking about assertions, we can visualize expectations. So I might set an expectation that a variable is not missing, and want to check that against an existing or a cleaned version of that same variable. So often in this iterative process, we'll want to include both the before and after columns after our particular fix to make sure things are going well. So using assertions and visualizations in kind of a loop can help make your pipelines a little bit more resilient. And then finally, I really like Skimmer, the skim function from Skimmer, which also gives you a quick overview of your data, but that you can use the outputs of in assertion pipelines and things like that. So you can check things over time and compare different data sets month over month. So in conclusion, you are probably not always able to treat your data like crops and not houseplants. But if you stay general, if you encode your assumptions, and you don't forget to look at your data, you can make those houseplants more resilient to changing conditions. You can make them more communicative when errors do arise and give you more reasonable error messages, and they can make you more adaptable when the unexpected occurs. So I wanted to throw up this this slide of all of some of the packages and functions we sort of walked through that I found really useful, and also wanted to plug a couple of other reproducibility resources. We didn't really talk about sort of the first steps of reproducibility, in large part because I think other folks have done this really well, both here in the Art Ladies meetup and otherwise, but wanted to share some of these resources for folks who are interested in learning more. And this should soon be on GitHub if it's not already. I think I've linked these slides, so feel free to go to that link. I think I detected some mistakes and errors as we were going through, so I think maybe that's the note that I'll leave you with. But also, you can, if you are on Twitter, you can reach out and connect with me. If you're not on Twitter, congratulations on your mental health. And the original post that I wrote as part of the ACLU Tech and Analytics blog is also linked here as well. You can email me.
Excellent. Thank you for that. Great presentation. So many questions that I don't see any questions in the chat yet, but I definitely have a lot of questions, so I'll ask all of mine. But if any of our attendees have any questions, then yeah, please go ahead and type those in the chat, or yeah, or raise your hand and you can come off of mute and share your question. Let me see, put my video back up. Okay, good. So yeah, my first question was about your work at ACLU, specifically about how you're using R at ACLU. And so I just wondered if you could just talk about maybe how you guys are using R. Is it more for data cleaning? Are you also using it to build your models? Or are you also, is it more like R for data cleaning and Python for analyses? Or, are you also bringing in GitHub and deployment to RStudio Connect or Shiny? Like, what are you guys doing with R there?
Yeah, that's a great question. We are a very R-heavy shop. We try to be bilingual or trilingual even. So the way that the ACLU analytics team is structured is that we have 3 sort of pods that focus on different areas. So we have one pod that focuses on engagement analytics. So thinking about understanding our members and supporters better, making sure that people are interacting with our website in good ways, and better understanding, what of our content, our emails, our work are people most engaged with. And so that team works a lot with our development department, our communications teams, a lot of different sort of internal focused stakeholders, and tends to use the kinds of data sets that are more automated and more easily reproduced, which comes with its own set of challenges for sure, but that has a more sort of a robust data infrastructure. So a lot of that pipeline is built in SQL and reports out into dashboards, and that sort of continuously updated as people are donating and things like that. Those our development heads can understand how and when people are donating. We have another pod that focuses on data infrastructure. So a lot of the underlying pipelines that support that team's work, but also when we need to scrape data from for a legal case or for a policy that we want to do, that's the team that we lean on, and also does a lot of our sets up a lot of our systems. So we do use RStudio server in-house. We have a couple of ways that we can use RStudio Connect as well. And then the team that I'm focused on, that I lead, is focused on supporting our legal analytics and quantitative research. So often that's supporting active litigation or helping our lawyers identify prospective litigation, or conducting analyses for quantitative reports for our advocacy teams to take to legislatures and things like that. And this team does use both R and Python, probably R a little bit more frequently, I think, for basically everything from data cleaning and data processing all the way through to building models, running simulations, doing analyses. We try to use the best tool for the job, and sometimes sometimes that's Python, but very frequently it's R.
I'm happy to hear you say that because, yeah, I think we all tend to have our favorite tools, especially for people who are coming out of some kind of graduate program or bootcamp program where you've become proficient in a particular tool, and then you get to your new employer and you realize they use the other tool or something else, right? So it helps to be flexible, and so that is really good to hear that that's how it plays out in practice as well. So thank you for that comment. Samantha Estrada has a question. She says, it's a silly question. Where do I get the Star Wars data? I teach undergraduates. So I guess you think so.
I think it's embedded in one of the Tidyverse packages. So I think it is just called Star Wars and comes when if you load the Tidyverse. I think it maybe is specifically in PER. And it's a good teaching data set because it has a lot of nested list columns. Mm-hmm. And all kind like different kinds of variables. So certainly in the Tidyverse, maybe in PER. Trying to check right now.
Okay. Yep. And if you can, whenever you figure it out, then that's fine. We could share that. I'll definitely be sharing resources after the talk's over on the meetup page. So yeah, definitely check back for that. I was just also looking at your bio and I saw that you had quite an interesting journey from biology to director of legal analytics and quantitative research at the ACLU. So that's quite a quite a path. So I just was wondering if you could talk through maybe how you pivoted from maybe that biology career to one that was more analytical.
Sure. Yeah. So I started out in biology in undergrad, and then worked for a few years before realizing I wanted to get more formal training in the pieces that I liked about research. I was never a good like wet lab scientist, and went on to have a bunch of different kinds of jobs before going back to grad school. But realized that statistics and public health were the pieces of sort of medical science that I was the most interested in. So went and got my master's degree in epidemiology and worked in that field for a couple of years before realizing essentially that this thing that people were starting to call data science was a lot like the research that I was doing, and a lot of the tools that I was using in my role at the Eco Health Alliance were the same that were asked for in a lot of job descriptions. So was lucky enough to, as I was considering these changes, come across a data scientist role at the ACLU, which I was a huge supporter of, but didn't realize that was an organization that would need data scientists, and in fact was really, really early in the analytics team at the organization, which started in 2018 and sort of grew out of this growing need for more tech and data professionals, and in I think a lot of nonprofit sectors that are moving in this direction. So happened to get to hit the ACLU as that team was growing, and found it to be a really symbiotic relationship with a lot of our legal departments who often have to make statistical cases for things like if they're trying to prove disparate impact in a legal case. You often need a statistician if they're trying to show disparities across a lot of different axes. And often we're working with folks in academia, but for really high rates, and it just helps to have that kind of experience in-house. So my team is, I get to work with a bunch of really, really smart political scientists and data journalists and analysts, and support a lot of the just brilliant lawyers that do our work.
Of course, I'm muted. It's so cool to just see that there's not a single path into data science. I think a lot of people just assume that you have to study math or statistics, and that's the only way in. But yeah, it's just, so cool to see your journey. So that is awesome. Nico wonders if you have any recommendations for messy data sets.
Oh gosh. I feel like all of the data sets that we have have to work with are messy. Is that recommendations for dealing with messy data sets or for practicing on messy data sets?
So, was that you?
Okay, yeah, sorry about that. I was just gonna say, yeah, because I'm actually, the company that I work for, we're looking for a way to kind of gauge new applicants, right? And so one of the things that we deal with is messy data sets, but we often get client work. So one of the challenges that I run into is trying to find like a messy data set out in the wild, whether from like a government listing or something along those lines, then just assess those applicants' ability to, I guess, develop reproducible and resilient strategies to clean and process data.
Mm-hmm.
So
for testing applicants' abilities to, like in a hiring setting.
Exactly right.
Yeah, I think so. I might not be the best person to give examples of those. I think a lot of the kinds of data sets that we deal with are pretty heavy and wouldn't necessarily be appropriate in a hiring context. But I do think that sort of data from the wild can be really useful. So like toy data sets that are scraped from the internet often can present a lot of challenges and have a lot of that like raw mess associated with them. So that might be a good place to start. And I've seen people use movies or music or artist catalogs and things like that that are maybe a little bit lighter and more have a lot of the same kinds of challenges.
Great. And another question from Stephanie Lepp. Stephanie Lepp Hickey. She says, I love your blog. How have your fun art projects helped you professionally?
Yeah, it's a great question. I don't think I've done a ton of fun art projects or had as much time to do fun art projects since being in this role as I did previously. But I do really think having a technical blog, doing art projects, kind of showing my work on the side as I was trying to make the case to employers that I did have the sort of technical skills, pivoting into a role that had the title data scientist, which I think a lot of folks who don't have that title have those skills. I think helped me get talks like this one. I gave a talk at the New York Art Conference that on a sort of like fun side project that helped introduce me to a lot of folks. I think it gave me a lot of good practice, like Nico mentioned, and maybe that's like a place to give sort of messy data set examples and it just in people's technical blogs. But I think it's improved my skills and helped me meet a lot of interesting people and know about roles. I would be remiss if I didn't mention that the ACLU is currently hiring a special assistant for digital tech and analytics, which is not technically a data role. It's more of an assistant role, but our current person who is going off to grad school gets to do a lot of data work and practice a lot. So for folks who are interested in entry-level roles.
Sure, and if you have information about that, maybe a link, then afterwards I could also share that in case people are looking. That's awesome. Cool.
Thanks for your answer. I just wanted to say that the organizers at Our Ladies East Lansing are obsessed with your Beyonce baby names analysis. So fun. Thanks for talking about.
Excellent. Wow. Well, now I'm curious. I have to check it out. I hadn't seen that one. That's cool. Okay, Stella. So before we go on to Stella's question, I'll just kind of maybe give another comment on that. So I've definitely done a lot of art projects, just projects in general outside of my day-to-day work. And that helps me in a lot of different ways. It helps me to learn new skills. So a lot of times it gives me an opportunity to practice some new technology or some new modeling strategy or something like that. But it also gives me things to talk about when people invite me to go to different conferences or other kinds of speaking engagements. And so that does increase my visibility in the professional, the scientific community. Gives me just something to talk to people about. So I definitely encourage you to work on some projects and share it with other people, whether it's in sessions like this. Shameless plug for our speaker lineup. If you're interested in talking about any of the art projects that you're working on, we would love to have you. Okay, so Stella has a question. She says, great talk. How do you stay current on packages and data science trends?
Oh gosh, I feel like I really don't. The main way that I do, honestly, is through my coworkers, many of whom are sort of spending more time in the data than I get to as frequently now. And so, and also, honestly, sessions like this, like Our Ladies broader community, both virtually and IRL and on the internet, is I think probably the number one source of my understanding about new trends and new sort of functions in data science. Unfortunately, Twitter is a big source of information, but I think like Slack groups as well, and just general data science communities.
Yeah, there's so much information out there. It's hard to figure out what to pay attention to. Yeah, there's lots of podcasts and blogs, and someone gave a plug for our bloggers, r-bloggers.com. There's a link in the chat. So yeah, those are all great tips. I had another question so I know we talked about your ascent into your current role, but given that this is Our Ladies, and so, you know, our audience is primarily consisting of women or people who identify as women or non-binary, we were just wondering if you had any tips or any sort of career advice specifically for women or non-binary people who are just wanting to have a technical career, a successful technical career. Just any advice that you could give.
Yeah, I think having a community of other technical women and non-binary people in sort of like in my journey has been really helpful. It's given me the safety to ask dumb questions in a safe space. And I really think asking questions is the quickest way to learning. And sometimes people who are underrepresented might not feel that comfortable asking a question. Like if you're the only woman in a room full of men who you perceive as being highly technical, it might feel harder to ask those questions. I've also been really lucky to work on teams that are led by really technical women. My boss is a really brilliant sort of like technical woman in tech who has built a team that has a lot of different kinds of voices. So that sort of community has been the most vital piece for me.
Great advice. Thank you for that. Any other questions or comments for our speaker before we wrap? We still have a few more minutes. Maybe I could ask, so I know you mentioned that you guys are hiring at ACLU. So is it that people who work on initiatives, the initiatives that you work on, are they generally employed by ACLU, or do you also take other help from like volunteers? Like what does that look like?
Yeah, it's a great question. And we're sort of trying to figure out how to, if and how we can use volunteer talent. So we have a really robust internship pipeline that is probably currently the least involved way that you can be involved. The most involved way being coming to work for us full time. But have a lot of volunteer opportunities for that are not specifically technical currently. And if folks often do want to connect particular affiliates within the ACLU network to folks who do consulting or can do projects one-off, academic folks, things like that. So you can feel free to reach out directly to me if you take projects like these. Also, don't definitely check on our careers page, aclu.org/careers, which will soon have our fall internship opportunities and also has that role that I mentioned.
Okay, perfect. So we don't have any other questions. So I'll definitely just take this moment to thank you, Brooke, for joining us today. I definitely learned a lot. I was scribbling lots of information about some of these packages that I just hadn't even heard of before, that I'd like to explore and possibly use in my work. So I hope everyone learned something. I'll connect with you and maybe we can, get those links to the role that you mentioned, and also to the resources that you shared, your slides and so on, whatever you want to share with everyone. And this will be recorded and available on our YouTube channel afterwards. So stay tuned on the Meetup event page and also on Twitter, where I will be publishing the link. And I think that's going to be it. Any last words or anything before we wrap?
Just thank you so much, Sadika, and thank you, Arlie, Zalis. It's really special to be in this space, and I think happy to see everyone and appreciate your time.
So great to meet you. Thank you for accepting our invitation to speak to us tonight. And yeah, definitely looking forward to learning more about you and connecting with you further. And with that, I think we will wrap there. Thanks everyone for coming. And I'm sure it's middle of the night in some places of the world. So thank you for joining us from wherever you are. Yeah, absolutely. Thank you all as well. Thank you, Casey. Okay, and yeah, I'll end it here. Everybody have a good evening.
Thank you.